In this lecture, we'll be studying about remote procedure calls. In the previous lecture, we have been studying about inter-process communications, and we have seen how inter-process communications take place using the shared memory systems, and also using the message passing systems. And we have also studied about sockets, and we saw how sockets help in establishing communication between processes. So till now, the inter-process communications that we have studied about, we're mostly based on local process communications. That means we were seeing how processes that resides in the same system communicates with each other. Now remote procedure calls come into play when we want processes that are residing in different systems, connected over a network, wants to communicate with each other. So think of a scenario where one process that is residing in a system wants to communicate to another process, which is residing physically in another system, and these two systems are connected via a network. So in this kind of scenario, we need to use remote procedure calls. And remote procedure calls will help us in communication between processes that are residing in different systems, connected over a network. So remote procedure call, or RPC, use a protocol that one program can use to request a service from a program located in another computer or a network without having to understand the network's details. So RPC is a protocol that helps one program to request a service from another program located in another computer on a network. And it does so in such a way that the processes that are communicating does not need to understand the network's details. So the network's details does not have to be understood by the processes that are communicating. So RPC takes care of this. Notice, RPC is similar in many respects to the IPC mechanism. So we have studied about IPC, which stands for inter-process communication. So RPC is similar to IPC in many ways, however, because we are dealing with an environment in which the processes are executing on separate systems, we must use a message-based communication scheme to provide remote service. So though RPC is similar to IPC in many ways, the difference is that, since in RPC we are dealing with an environment in which processes are executed on separate systems, we need to use a message-based communication scheme. So if you remember about the two communication schemes that we have studied about shared memory system, and we have studied about message passing system. So in shared memory system, what happens is, when the processes wants to communicate with each other, there is a region or shared memory that they have. And the process that wants to communicate just writes whatever it wants to communicate on the shared region, and the other process just reads from that shared region. But in case of RPC, we are dealing with processes that are residing in two different systems that are connected via network. So in this kind of a system, it may not be possible to have a shared region of memory. So that shared memory system may not be possible. So we have to use the other kind of communication scheme that we have studied, which is the message passing system. So in RPC, we will be using a message-based communication scheme. So moving on, let us see what are the other differences that RPC has as compared to IPC. So in contrast to the IPC facility, the messages exchanged in RPC communications are well structured and are thus no longer just packets of data. So in case of IPC, whenever we use the message passing systems, those messages were just packets of data and nothing else. So if you remember, when you studied about message passing system, the process that wants to send the message just sends that message as a packet to the kernel, and from the kernel, it goes to the process to which that message was intended to. So messages were just back at some data. But in case of RPC, it is not just happening in a single system, has to travel between one system to the other system. So we cannot just keep our messages as simple packets of data, but they have to be well structured, because they have to travel over a network. So each message is addressed to an RPC daemon listening to a port on the remote system, and each contains an identifier of the function to execute and the parameters to pass to that function. So in case of RPC, whenever the message passing takes place, that means whenever one process wants to communicate to another process residing in another system, the message is sent in such a way that the message is addressed to a RPC daemon, which is listening to a port on the remote system. So by daemon, we mean that a program which is always listening, or which is always on, and is always listening, and is waiting to get some input. And based on that, it will work. So this RPC daemon is always listening to a port on the remote system, waiting for some incoming requests. So we have also studied about the concept of port in the lecture where we discuss about sockets. So if you have not seen that, I request you to kindly watch that lecture where we have discussed about ports and how ports are assigned to different processes. So as we were saying, in case of RPC, when the message is sent, it is addressed to the RPC daemon, which is listing the port on the remote system, and each of the message that is sent, it contains an identifier of the function to execute and the parameters to pass to that function. Now we are using the term function here. So what is a function? So when we study programming, we know what our function. So function is a piece of code that is written, which performs a specific task. So what are the requirements that we need in a function? The function needs parameters. So based on the parameters, the operation is performed on that parameters, and something is returned. So in case of RPC, think of this function as a service, which is going to be requested by one process from the other process. So there is a process residing in a system, and this process wants a service, which is provided by another process residing in another system. So think of that service as a function. So what do? We have to pass the parameters of the function, and we have to call the function, and then the function will be executed. So in the same way, in this RPC, we have to pass identifier of the function, which may be like a function name, and then the parameters that we have to pass the function. Then after that, what happens? The function is then executed as requested, and any output is sent back to the requester in a separate message. So let's take the example of a simple function in programming. Again, what happens when we call a function? When we call a function, we pass a parameters, and when the function is called, the function gets executed, and after execution, if there are anything to be returned, that will be returned. And where will it be returned? It will be returned to the place where the function was called. So in case of RPC, who is the one who called the function or the service, it is the first process or the client. So after the function is executed in the other system, the things that has to be returned, the return value has to be passed back to the client again, and that will be done in a separate message using the message passing system. So that is basically how the RPC functions. So we have seen an overview of how the RPC functions. Now let us see how does the semantics of RPC allow a client to invoke a procedure on a remote host, as it would invoke a procedure locally. So we already know how processes communicate in a local setup. That means when they are residing in the same system. So in case of RPC, when the processes are residing in two different systems connected over a network, let us see how does the communication take place. So the RPC system hides the details that allow communication to take place by providing a stamp on the client site. And typically, a separate stub exists for each separate remote procedure. So, as I already told you, RPC system, it hides the details that allow communication to take place by providing a stub on the client side. So when we use this RPC, the process does not have to be concerned about how the communication takes place. RPC hides the details of that. And how does it do? By providing a stub on the client side. And we will see what is a function of this stub as we move ahead. And typically, a separate stub exists for each separate remote procedure. So let us move ahead and see what is a function of this stub. What does it do? And how does it proceed? So when a client invokes a remote procedure, the RPC system calls the appropriate stub, passing it the parameters provided to the remote procedure, and this stub locates the port on the server and marshals the parameters. So when a client invokes a remote procedure, that means when a client, a process in one system, wants to get the service of the process residing in another system, what does it do? It invokes that procedure. The client invokes the remote procedure. We use the term remote because it is residing in another system, not in the same system. So when the procedure is invoked, what happens? The RPC system, it calls the appropriate stub, and then it passes the parameters provided to the remote procedure. So whenever we say remote procedure, think of it as a function that we have written in a program. What does it do? It executes something. It provides a certain service. So what is required? In a function, we have to pass a parameters to a function. So when the client involves remote procedure, the RPC will call appropriate stub, and it will pass the required parameters that are provided to the remote procedure. And then this stop locates the port on the server and marshals the parameters. So the stop will locate the port on the server. On the server, there will be different kind of services that will be available, and each service will be identified by a port number. So we have discussed about port in the previous lecture, where we studied about sockets. So that specific port has to be found out, so the stop will do that part. It will locate the port on the server, and it marshals the parameters. That means it will combine the parameters in a specific way. So let us now understand what the meaning of this term marshals. And what is the meaning of the stop marshals the parameters? So parameter marshaling involves packaging the parameters into a form that can be transmitted over network. So we got all the parameters that were required for the function to execute. And where is that function? Keep in mind, it is in the server side. It is the remote procedure that we are going to invoke. So we have all the parameters to be passed to that. And parameter marshaling involves packaging the parameters into a form that can be transmitted over a network. Since the procedure is residing in another system, this parameters has to be passed over the network to the other system. So since it has to travel through the network, the parameters have to be in a form that can be transmitted over a network. So parameter marshaling means it will package the parameters into a form which can be transmitted over the network. So that is what we mean parameter marshaling. The stop then transmits a message to the server using message passing. So now everything is ready. And after it is ready, the stop will transmit the message to the server using message passing system. So we have passed the message from the client side to the server. So what happens on the server side? A similar stub on the server side receives this message and invokes the procedure on the server. So just like we had stub on the client side, there is a stub also on the server side. The stop on the server side will receive the message that we have sent and what was therein. The messages, the parameters, were therefore the function to be invoked. So that function will be invoked using the parameters that was passed, and the function will be executed right. So what will be the last step when we are executing a function in a program? What is the last step after the function is executed? The result has to be returned to the place where the function was called. So if necessary, return values are back to the client using the same technique. So similarly, in this RPC, after the function is executed, that means after the service has been executed, if there are any return values, it has to be passed back to the place from where the service was called. And from where was it called? It was called from the client side. So those return values has to be passed back to the client. And how is it passed back? It is passed back by using the same message passing technique. So this is how basically a remote procedure call works. So we have seen that remote procedure call is something that is used when communication has to take place between processes that are residing in different systems connected over networks. So this is the basic working of an RPC. Alright, though, we have seen the working of an RPC during this procedure. During this entire process, there are certain issues that we face, and this issues has to be considered. This issues has to be addressed, and there has to be some way this issues have to be resolved. So, in the next lecture, we will see what are the issues that are faced by an RPC, and how are those issues resolved, and after resolution of those issues, we will see as a whole how our PC works. We have already seen how our PC in this lecture, but we also have to see how are those issues tackled when they are encountered. So we will see the entire working of an RPC after resolution of all those issues in the next lecture. So with this, I hope the basic concept of RPC was clear to you. Thank you for watching, and see you in the next one.